Hello my dear students, you are welcome to World School of Mathematics. Sudipsir.math here, discussing about relations. That is for relation function mapping, relation part. Okay. Now for relation, we have to know about order pairs. Say if A equal to 1, A has 1, 2, B has two elements A, B. Then what are the order pairs A, B? For A, B, it will be 1, A, 1, A, 1, B, 2, A, 2, B. These are the order pairs for A, B. For B cross A, it will be A, 1, A, 1, A, 2, B, 1, B, 1 and B, 2. These are the order pairs. These are the order pairs. Now for relation that R belongs to R subset of A, cross B, all R subset of A, B are treated as relation. All subsets of A, B are as relation, and there will be different type of relation. Before that relation, we have to know for any relation, say for A equal to say 1, 2, 3 and B equal to 4, 5, 6 is taken. Now one of the relations, suppose 1, 4, 2, 5, 3, 6, one relation is taken. Now for this domain of R equal to 1, 2, 3. Array and range of R is 4, 5, 6. That is this our domain, and result will be range. And R inverse, one thing, R inverse that will be domain into range into domain. R inverse will be like 4, 1, 5, 2, 6, 3. This is the R inverse. For R inverse, domain of R inverse for this 4, 5, 6, which is range of R and domain of range of R inverse 1, 2, 3, which is domain of R. Now for this relation, different type of relations are there. That was inverse relation. Now different type of relation, types of relations, different types of relations. Void relation, this does not, but that is phi. 5 subset of A cross B, so does not have elements. For example, if A equal to 1, 2, 3, 4 and relation is like this, relation A comma B, set of A comma B such that AB greater than equal to 20. Now for this we will get different order pairs like A cross A, different order pairs like 1 comma 1, 1 comma 2, dot dot 4 comma 4. But it is clear maximum product, maximum AB is 16. So AB greater than equal to 20 not possible. So this R is said to be void relation. This R is said to be a void relation. Now universal relation. For universal relation, A cross A subset of A cross A. For example, say A equal to 1, 2, 3, 4 and relation is like A comma A such that AB greater than equal to 0. So for all order pairs A cross A, 1 comma 2 like this up to 4 comma 4. So all order pair 1 into 1, that is 1 greater than 0, 1 into 2, that is 2 greater than 0. So all are like this, all are greater than 0. So this relation is said universal relation. This is the universal relation. Now another relation is identity relation. For identity relation, for identity relation, IA like A comma A such that A belongs to A. For example, if A has 1, 2, 3, then R1 if 1, 1, 2, 2 and 3, 3, then R1 is identity relation. All A comma A must be present. Say R2 1 comma 1, 2 comma 2. So this is not an identity relation because 3 comma 3 does not belongs to R2. So all must be present for identity relation and should not have any more element also. That is R3 1, 1, 2, 2, 3, 3 and say 4, 1. No, say 1, 2. So this will not be treated as identity relation due to this element. Due to this element, we can't say this is not an identity element. It will be reflexive element, reflexive relation. I am giving about reflexive. Next, reflexive relation. In reflexive relation, all A comma A must be present. All A comma A must be belongs to the relation. All A comma A must be belongs to the relation, that is A relation A. or you can say if it is A, then A maps on A. A relation on A. A relation on A. This is A relation on A. A relation on A. For example, if 1, 2, 3, then R1, if it is 1, 1, 2, 2, 3, 3, with that maybe 2, 1, this is reflexive relation. Remember, all identity relation are reflexive, but reflexive may or may not be identity relation. Due to this element, it will not be identity, but it is a reflexive relation. Reflexive relation. Now for symmetric, another relation is symmetric. Symmetric relation. For this symmetric relation, for the symmetric relation, for all A comma B belongs to R, A comma B belongs to R, must be B comma A belongs to R. That is A relation B. A relation B. Now for reflexive relation, another example, equal to, parallel to, congruent to, similar to, these all are reflexive relation. These all are reflexive relation because A equal to A or A parallel A, these all are reflexive relation. For symmetric relation, A relation B implies that B relation A. That is A to B will implies B to A. This is symmetric relation. And for symmetric relation, we can give example, equal to, A equal to B. A equal to B implies that B equal to A. Equal to, similar to, congruent to, similar to, these all are parallel to, these all are symmetric relation. But less than or greater than not symmetric relation. So in A, for same example 1, 2, 3, A equal to 1, 2, 3, if R equal to 1, 2, comma 2, 1, then this will be symmetric relation. Symmetric relation. Now another relation is transitive. Transitive relation. Transitive relation. Transitive relation. For transitive relation, if A comma B belongs to R and B comma C belongs to R, A comma B belongs to R, B comma C belongs to R, implies that A comma C belongs to R. That is A, R, B and B, R, C implies that A, R, C. A, R, C. That is A to B, B to C. This is B, this is C. It must be A to C. For example, A equal to, if A equal to 1, 2, 3, and one relation is like 1, 2, 2, 3, and 1, 3. This must be present 1, 3. Then it will be transitive relation 1, 2, 2, 3, 1, 3. If 1, 2, then and 2, 3, then 1, 3. Otherwise also one relation can be said 1 2 1 2 itself reflexive, transitive. 1 2 1 2 it is transitive, or we can say it is 1 2 and another thing 1 3 is there. But remember, if 1 2 2 3 then only this 1 2 and 1 3, this is also transitive. But say R4 1 2 2 3, now 1 3, this is not a transitive. 1 2 2 3, it must be 1 3. No, it is transitive. But if 1 2 2 3 and this is 3 3 1 2 2 3 3 3, so this will not be transitive. Okay. And another thing, antisymmetric relation. In antisymmetric relation, if A comma B belongs to R and B comma A belongs to R, A comma B belongs to R and B comma A belongs to R, implies that A equal to B. Implies that A equal to B for all A comma B belongs to A. For example, if A divides B and B divides A, it must be A equal to B. If A divides B and B divides A, it must be A equal to B. Or another example, if X greater than equal to Y and Y greater than equal to X, it must be X equal to Y. So this is also antisymmetric. So these are the conditions or formulas for relation. Go to our website and practice more. Okay. Thank you.